Hey y'all, Automation Doctor here. I know I haven't been keeping up my end of the bargain. I apologize. It's been a fairly chaotic holiday season, and I've got a little bit of a cold or something going on, so I don't know. My voice is probably terrible to begin with. Hopefully, it's not that much worse. Anyway, I thought I would go ahead and give you something of a riddle to torture your poor IT team if you'd like it. This isn't much of anything that you'll find useful, although the reason I found it did actually have a real bearing on a real-world device process that we had to troubleshoot and figure out why we were getting a weird response. So imagine, if you will, I can, in fact, come down to my command prompt here, and I can ping 192.168.1.1. I'm on a standard home network, and when I hit return on that, I get a good return coming from the number of bytes that I've sent, the amount of time it takes to get back from my modem, slash switch-ish, it's an all-in-one, slash, this is my gateway for how I get onto the internet, at least in this particular configuration. And this TTL stands for time to live. Just think of it as it can go through so many switches or devices before it eventually gives up and says, hey, I couldn't find that device. You'll notice that I get some statistics back, and it sees that. And similarly, I can ping 192.168.1.01, and to a human that should be the same, and to the computer here, 01 is in fact the same. However, something that you will find perhaps that is of interest is that if I ping 192.168.1.09, we have something rather interesting happen. Well, we couldn't find a device at .09, so I don't think I have anything actually set up at, really am an engineer, 2.168.1. Let's do 010. You'll notice that at 010, it's actually trying to ping .8. And this is where you could torture your poor IT team and go talk to them. And if you don't want to know why this is, I encourage you to go ahead and stop the video right here and go do some independent research. That said, if you'd like to know, I'm going to go ahead and reveal. The fact remains that computer systems have been around for a lot longer than we have had modern systems. And modern systems have memory in absolute spades. In a time when we did not have lots of memory, there was a numbering system known as octal, otherwise known as base 8. And as it turns out, 10 in base 8 is equal to decimal value 8, which you can see right here. And as it turns out, in the olden days, there was need to use an octal system for some things, and one of the ways that you would denote that you were looking at an octal number is you could have a leading zero. Now, in the modern world, we would usually do something like an 8 or a subscript 8, or we would have some other method of denoting that this is an octal system. But in the old days, memory is expensive. And because it's expensive, we have to denote things rather quickly. And so a 0, for whatever reason they decided back in the day, denoted that this is an octal value. So this is octal value 10, which in a base 8 system is equal to 10. And if you're not sure why that is, go ahead and leave me a comment, and I'd be more than happy to go over how different numbering systems work. There are probably better groups out there that can explain this to you, but if you want to torture your poor IT team, this is exactly how you can do it. Say you have a device at ping, say I've got it at 192.168.1.20, and this is actually going to try and ping, I'm sorry, .20 is correct. If I cancel that out and I say ping 192.168.1. with a leading 0 indicates that this particular octet is an octal number, and now if I hit 20, it's trying to go to 16, and that is because 2 multiplied by 8 is 16. Again, if you're not sure how numbering system works, different numbering systems work, I'm more than happy to go over this at a later date. Again, very short video today, just showing you something that I know tortured my own IT team, and so I'm now giving it to you as a fun riddle to give them. Anywho, you all have a good one, and I will catch you next time.